Last class, one thing that we cleared up that is that the inverse function is a function. It's not the opposite of a function, which is what people were thinking, like opposite of a function means it's not a function. A lot of people had that thought, and it was really good that we cleared that up. That's not what it is. It has to be a function, and it's a function that will undo another function. So the inverse of a function undoes a function like antidote would undo a poison. The way it works is that the domain and range of these relations and functions switch places, remembering that domain means x and range means y. The x and y will switch. The notation for the inverse is really weird and confusing because the notation looks like a reciprocal, and it is not usually a reciprocal. It could be, but the notation is this. It looks like f to the negative 1. It is not f to the negative 1. It's really just read inverse of f, but so it's not to be confused with f of x to the negative 1. That one would be a reciprocal. Okay, so this one is inverse, and this one is reciprocal. So last class, what we learned was when you input a negative 1, you'll get out some other number, but then you take that number and then you go back to your original number. So in this case, negative 1. In this case, the 0 goes to 1, then the 1 gets you back to 0. The 1 goes to 2, then that 2 has to get you back to 1. And the 2 goes to 4. Oh, sorry, I can't read that number. What does it say? Yeah, 4. And then the 4 has to get you back to 2. And what happens essentially is that your ordered pairs just switch places. So you just switch the x and the y. And if you were here last class, we looked to see what would that look like on a graph. So we named our points. This is negative 1, 1/2. This is 0, 1, 1, 2, and this one is 2, 4. And then we switched the x and the y. So this one would become 1/2 negative 1. And this one would become 1, 0. This one is 2, 1. Notice I'm just switching x and y. And then the last one is 4, 2. And then last class, some of you noticed a relationship across this line y equals x. What's the relationship between the points and their inverse? Issa?
Oh, I don't know. But I have a question.
Okay, go ahead.
Would it only reflect over the
That's exactly what it is, right? So you answered my question even though you didn't want to. Yes. So the points and their inverse will always reflect across the line y equals x. Okay? So what do you notice? They reflect across the line y equals x. Some people are really good visual mathematicians, and some people are really good algebraic mathematicians, and some people are both. For me, I'm not really good visually, so I just need to see like the numbers switch and then I get it. But some people can see that reflection really well. All right, so on a graph, we're going to identify points and then switch the x and y values. And when I identify points, I want to identify points that are really clear. Like this point right here, I can't tell if it's at 1.5 exactly. So I'm not going to pick that one. I'm going to pick this one. And then I could also pick this one here. So that one is 0, -3. And this one is 2, 1. And so I'm going to switch them. This will become negative 3, 0 over here, and 1, 2 here. If you have any sort of straight edge, just the side of a folder or anything, you can use that, and you'll see, just like Hassan predicted, that it's going to go through and look like a reflection across the line y equals x. We talked about the intuition way and the algebraic way, and you don't need to understand both, you just need to understand one, okay? So for the equation, intuition, that's what we kind of worked on in our investigation. You have to undo the operations, but you have to do the order backwards of the original order. Okay, so undo operations, backwards order. All right, and then algebraic, you switch x and y. And then you solve for y. And so here's the example. We're going to do the example both ways. So intuition. In the original function, first we multiply by 4 and then we add 1. So if we're going to undo that backwards, which one do we have to undo first? Remember, we're going to do a backwards order of the original. The original was multiply by 4 and add 1. So first we have to undo what? Yes, so first we're going to undo the add 1 with minus 1. So we would start with y equals x minus 1. And then we have to take that answer and do what to get rid of the multiply by 4? Divide by 4. Okay, so we did it in one step with intuition. However, some people still have trouble following that, and that's okay because there's another way. There's the algebraic way. In the algebraic way, we do, like Blaine told us last class, we switch the x and y. And then we have to get the y by itself. So to get the y by itself, I would start by subtracting the 1. And then I would undo the multiplication by dividing by 4. Now, I'm just not 100% sure if Delta Math likes this as your final answer, so I'm going to show you another way that you could write your final answer. For me, this is okay. This is simplified, but they might like it this way. We divide each 1 by 4, so it would be y equals x over 4 minus 1 over 4. And if they want to write this with a coefficient, that would be y equals 1/4 x minus 1/4. So for me, this is okay. If you're having trouble with Delta Math, continue with steps like this where you divide each 1 by 4. We'll work through Delta Math today and we'll see what works and what doesn't work. Okay. Let's do number 1 with intuition. Notice it has an f of x. Anytime it has an f of x, we're going to end with the different notation, that inverse notation from the front. Okay, so the inverse notation is this. And what is the inverse of subtracting 1? Adding 1, yeah. So it's just going to be x plus 1. All right, so really simple one. You can just use your intuition. You don't have to do all those steps, but notice the notation. That's the notation, okay? So I did that one with intuition. Notice I'm going to use blue for intuition. I'm going to use red for algebra. I'm going to try to remember to do that. I'm really bad at remembering, though. All right, so I'm going to do number 2 with algebra, and then I'm going to give you guys a minute to try 3 and 4. I gave you the hard ones. All right, number 2. F of x is a fancy way to say what?
Y.
She's right. F of x is a fancy way to say y, so I'm going to remember that and just cover it with a y. I still have to get back to my inverse notation at the end, but in the middle, I'm going to use x and y. Now, I'm going to switch the x and y, so I'm going to do x equals 2y plus 8. And I have to get the y by itself. So I'm going to subtract the 8. I don't want to lose track of what problem is which, so I have x minus 8 equals 2y. So those cancel. And then I'm going to divide by 2. And I get y equals x minus 8 all over 2, which you can divide out, but you've seen that happen already. All right, what questions do you guys have on 1 and 2 before? Oh, wait, I didn't do the notation. The notation is the inverse notation, so it goes back like this.
You have to put the inverse notation.
You have to use that notation if the problem starts with f of x. If it starts with y, then you can just do y. Okay? If you're ever in doubt, you can do the inverse notation. I will never mark that wrong.
Okay.
So it's inverse of f of x equals x minus 8 over 2. Okay, I'm going to need some volunteers because we're going to have to go through these both ways. I want to make sure that you understand the method you used, which might be different from the method that your peer used. You ready?
Yes.
Okay. All right. Izzy, I know you used intuition for number 3. Can you tell us what you did first?
First, I knew that the inverse of adding 4 was subtracting 4.
Good.
And then I knew the inverse of cubing x was like the square root was the little 3.
Cube root.
Cube root.
Yeah, good. Okay. So first she subtracted 4, and then she applied cube root to the whole thing, and that was the intuition method, and it worked. Raise your hand if you use the algebraic method for number 3. Anybody use algebraic? Steph, good. Can you tell us the first step? Wait, did you switch the x and y first? Okay, sorry. Guys, if you are not getting the intuition method, please follow Steph's... Oh, it's frozen? Sorry. If you're not getting the intuition method, please follow Steph's steps for algebraic. First, switch, and then I think you said subtract 4, right? Okay. So x minus 4 equals y cubed, and then what'd you do?
And then I undid the cube and the y, so I cube rooting x minus 4.
Excellent. So cube root on both sides cancels out the cube, and you get the same answer. Steph and Izzy got the same answer. Okay. I'm kind of curious about what you guys are doing. Raise your hand if you prefer the intuition method. Okay. Raise your hand if you prefer the algebraic method. Okay. All right. They're both good, whichever works for you. All right. We're doing the next one. Are you ready? Okay. Gideon, I think you did intuition for number 4, right? Yeah. Can you tell us what you did?
I just did the inverse of equation, so it's like x minus 5 over 1 over 2.
Okay. So first you did x minus 5. And then because this is times 1/2, you did divided by 1/2. Let me stop there because I want to make sure everybody's getting that. So even though he used intuition, it did end up that there's an extra step in this one. Because having a fraction in a fraction is not completely simplified. So then you change dividing by 1/2 to what? Good. Can you read to me what you wrote? Uh-huh. Good. All right, so this notation shows that you are multiplying the whole answer to x minus 5 times 2. Okay, and you can distribute that, but what you don't want to do is write it without the parentheses. So make sure that in that previous step, if you have something like 2 times x minus 5, you have the parentheses like Gideon did, and then you can choose to distribute it. All right, raise your hand if you can share with us the algebraic method for 4. You don't have to do the problem twice, guys. I'm just doing it twice to show you. Both methods. Hassan, did you do it? Can you tell me the first step? Good. All right, hold on, I'm catching up. 1/2 y plus 5. You subtracted the 5? Okay. Then what did you do? Okay, so then you ended up in the same place as Gideon. And then did you switch it to times 2? Okay.
Those equations like give you the same answer, right?
Yeah, so you could do the blue, the intuitive method, or you can do the green, the algebraic method. They should both work for you, okay? Switching x and y, it does make sense mathematically, but it almost seems like a trick when people do it without understanding why they're doing it. But it works, and it's okay as long as you're understanding what you're doing. What questions do we have on those before we get to our last section? Okay, there are a lot of words here, so please bear with me. So, sometimes a function does not have an inverse. So, let's graph this equation. Oh, I told you to tilt your screen. Let's open your screen and graph this equation in Desmos, and then switch the x and y. And we're going to see whether or not the inverse is a function. So I'm also going to do that, but I'm really recommending that you try it too. That's the wrong one. Try again. So my equation was y equals 5x squared minus 1. All right, so the first one was a function, right? Passes the vertical line test. Now I'm going to switch it. All right, so even though that's not solved for y, that is technically switching the x and y. So it should be an inverse, but the question is the blue one there a function? No, it does not pass the vertical line test. And remember, what the vertical line test is telling us is that there exists an x value that has more than one y value. It's kind of hard for me to zero in on the points here, but you can see that when x is 2, for example, the y value might be down here, or the y value might be up here, making it not a function. Okay? So sometimes a function does not have an inverse. Let's see. So we said no. And you can write vertical line test, or you can write x values have more than one y value. Okay. So if the inverse is not a function, the original equation does not have an inverse. A function will have an inverse if it is 1 to 1, which means not only does every input have one output, but every output has one input. So one output to one input, like this, not like that. A horizontal line test will tell you if the inverse will be a function. So let me go back to my Desmos real quick. All right, my red parabola here is a function, but by doing a horizontal line test, like here's a horizontal line. Okay, by doing a horizontal line test and the horizontal line crosses it twice, I can tell that the inverse will not be a function. Okay, so the red one is a function itself, but the inverse is not a function by the horizontal line test. All right, last thing, composition. Now, what we talked about in the very beginning when we started talking about inverse function is when you put in x and you get out some other number, when you put that number back into the inverse, you should get what number out in the end? If I put in x, what should I get out in the end? If I put in 2, what should I get out at the end? 2. Very good. If I put in x, what should I get out? I should get out x. Yeah. All right. So what we're going to do is combine our lessons 6 and 7. Lesson 6 was on composition, where you put a function in a function. If I put this function into the other function, and if they are inverses, I should get x out. Okay? So f and g are inverse functions if and only if f of g of x equals x and g of f of x equals x. So that means when I put g into f and when I put f into g, I'm going to get x as an answer. So if I ask you to prove if two functions are inverses, I am asking you to put one into the other and then do it the same thing but backwards to see if they're inverses. So we're going to do f of g of x. F of g of x. Okay, so f is on the outside. Something cubed plus 2. This is also reviewing lesson 6. If you're like, oh, I forget about how to do a composition of functions, that's going to be the lesson you want to review. And I'm going to put g inside. Okay, so my function f was cube something and add 2, and the thing I'm going to cube is the function g. Okay, and now I'm going to actually put that function in there. Okay, so I'm putting in the cube root of x minus 2. What happens when you cube a cube root? I heard it from one person. They cancel. Very good. So when you cube a cube root, they cancel. So now I just have x minus 2 plus 2, which is what? Just x. So that one worked. Good job. All right. Now, g of f of x. All right, my outside function is g. So I need to cube root something. The thing I'm cube rooting is something that's going to go in for x minus 2. And what I'm putting instead of x is f of x. All right, I'm going to cube root this one, x cubed plus 2, and I still have minus 2. Which makes the cube root of x cubed, which is just what? Just x. So that works too. All right. And then we write our conclusion. F of g of x equals g of f of x equals x. Therefore, this is a really cool way of writing therefore in math. Therefore, f and g are inverses.